Hello there, ATS EVS 105 students. Dr. Schrage here, and we're continuing our discussion about what are we going to do about global warming. I mean, we've kind of made a mess of things. We know that global warming is coming. The science is not really anything that can be argued with. What can we do about it? What are the plans? And as I told you a couple times in the previous lecture about adaptation, we're not going to really like any of the answers. Okay, there are no great choices. There are no great paths in front of us at this point. It's more a matter of, well, the truth of the matter is we still get to choose. We get to choose what the outcomes are going to look like. None of them are great, though. And so we get to have to decide and prioritize what's most important to us and so on. Now, last lecture we were talking about adaptation strategies. This was this kind of lack of a plan, for lack of any better word, where we just say, you know what, we'll just deal with it as it comes. As sea levels rise, we'll figure out how far we need to move people inland. As climate changes, we'll decide what crops can and can't grow in different places and so on. And no doubt about it, adaptation like that is going to have to be part of the strategy as to how we make our lives different in the presence of global warming. But there are better solutions, and one of the, well, different solutions in front of us, and one of them is mitigation. Mitigation is planning on when you make reductions in the emissions of greenhouse gases to prevent change or to avoid the worst impacts of climate change. We're going to do something now to make changes in the future as to how bad this is going to get. Now, there's actually a very closely related lecture coming up yet in this module that's about mitigation policies. What can we do as a society or as a government or whatever to make this kind of mitigation happen? That's not what we're doing today in this lecture. This lecture is about like the technologies and the science behind mitigating climate change. Alright, so remember in the last lecture we talked about the fact that adaptation is just a ridiculously risky strategy. We don't honestly have any idea what adapting to any of this is going to cost, who's going to be the winner, who's going to be the loser and all of it and so on. It's a ridiculously risky, it's not really a policy at all. And so mitigation is going to have to be part of our plan if we're going to ever get through to some kind of climate stabilization in the future. And so no matter what plan we come up with, no matter how much climate change is enough climate change or too much climate change depending on your politics and so on, we know that at some point we have to reduce our greenhouse gas emissions. Well, this means we can turn back to an old friend, the IPAT relation or the Kea identity, which can be written a couple of different ways as we've seen before. And we are going to start looking at this and saying, well, what can we do that actually results in a reduction of emissions? If that's going to be our plan, we're going to have a way to do some of these reductions here. Well, the P, remember, was population. So one thing that we could do to dramatically reduce emissions is to just have dramatically fewer people in the world. I don't know that anybody has a good plan as to how to do that, or even if we should. I mean, realistically, we'd have to cut birth rates basically to zero for many decades to make a significant dent in the size of the world population. That's just not, that's not something to plan around. We just can't make something like that happen. We shouldn't make something like that happen. There's ethical reasons and moral reasons and so on why that's just not even really an option. There just isn't any way that we could have a sustainable culture on our planet if we had to make the necessary reductions in population, P. What about A, affluence? I mean, I suppose a case could be made, by people with interest in things like sustainability, that reducing the world's affluence is a good idea, where we could, all use less, reduce, reuse, recycle, all that kind of good stuff. And that's admirable and maybe even part of the plan, but it's awfully hard to say we're going to reduce the affluence for the 1 billion people who are, living on $1 a day or whatever the statistic is, right? I mean, realistically, at a global scale, reducing the affluence means things like fewer kids get vaccinations or fewer kids get the proper nutrition and so on. Again, that's really hard to argue as an ethical thing. Yes, we as top consumers in Western societies and so on, yes, I would agree we can all live with less and so on, but as a planet, can we all do with less? That's not really, it's very hard to find a way to argue that that's ethical or moral or whatever. So the P and the A terms of the IPAT relationship turn out to be kind of off limits for cutting our emissions and mitigating climate change. That only leaves us the energy intensity and the carbon intensity terms. Well, energy intensity, that's the amount of energy it takes to make a dollar's worth of goods and services. Well, maybe we could make some big dents in this. Maybe we could make our goods and services more energy efficient. We could use less energy to make our products and so on. All right, well, how much would we need to be? Well, to be honest, I don't remember in the textbook exactly what their target was, but like to make some significant cuts in the energy intensity, like to be in compliance with Kyoto Protocol or the Paris Climate Accords or whatever, one of those kinds of things. They said there that we had to reduce the energy efficiency, we had to improve energy efficiency by, well, if we could do it without actually increasing the gross domestic product of the planet, we could reduce our energy efficiency, we could reduce our energy intensity by about 3% per year, and we'd achieve whatever the target was they mentioned in the book. If the gross domestic product of the Earth keeps increasing the way it has in recent decades, then we'd have to reduce our energy intensity by about 6% per year in order to, again, reach whatever target it was in the book. It's not tremendously relevant what the target is because we're not going to reach it anyway. Because it turns out a much more realistic number as to how much we can improve energy intensity each year is about 1%. Okay, when we look back over the last 100 years or so, we have gradually gotten less energy intensive in terms of how we do our manufacturing and our mining and our agricultural production and so on. But at a rate, 3 to 6 times smaller than what it would have to be making meaningful dents in our energy, in our greenhouse gas emissions. It's not that this isn't supposed to be part of the solution, but improvements of the energy intensity cannot be reasonably expected to make that kind of year-on-year improvements, where for, year and year and year for decades to come, we keep improving our energy efficiency by 6%. Okay? That's just not, there's no point in making expectations we can't meet. So it's part of the solution, but it can't possibly be the whole thing. Well, what about the necessary improvements in carbon intensity? Remember, carbon intensity is the amount of carbon dioxide released to produce a joule of energy. Oh, well, there we have a whole menu of options. Right now it's true, a whole bunch of the energy globally is produced by things like coal and petroleum and natural gas and so on, but it wouldn't have to be. Maybe we could do this. Maybe there are technologies out there that we could get the carbon intensity term to get lower. And see here, this is the nature of an equation like the IPAT relationship. If we can make any one of these terms 0, the whole thing goes to 0. And even if 0 is unreasonable, okay, small. If we can make CI small, a relatively tiny amount of carbon being needed for the average joule of energy being produced, the whole thing goes to a small number. All we have to do is fix one of the things on the right-hand side of this equation. We don't often get to see glimmers of hope in this class, but maybe we have a glimmer of hope here. Maybe we can make meaningful improvements in our carbon intensity. And that's what we're going to do in part 2 of the lecture class. But in the meantime, I want to ask a couple of questions here about these ideas that we've seen so far. Question 1. Which of these is a climate change mitigation technology? Now notice the word mitigation here, not one of the other strategies that we're talking about here. A, widespread use of solar power. B, building higher seawalls to protect coastal cities. Or C, increasing the amount of water available for irrigation. Which of these would be a mitigation strategy versus like an adaptation strategy or whatever? Take a look at those 3 options and make a choice. Get a little feedback before you move on to question 2.